Significant figures and error intervals are related to different ways of dealing with uncertainty in scientific measurements. So what's better, significant figures or error intervals? So I don't know, maybe I can make up a quick example here. Let's say somebody does a measurement and it turns out to be 12 meters. But I have a question about, like, well, how precise is that measurement really? So maybe one way of reporting that would be to say it's 12.00. This is, like, I know in chemistry classes, it's pretty common that you, like, if you want to say that this is more precise than exactly just 12, but it's maybe down to the nearest, centimeter or so, or maybe several centimeters, or maybe, maybe even smaller, whatever. But, like, if I wrote it like this would be indicating some level of precision. It would mean that I think that, like, my interpretation of this, it's a little bit fuzzy, it turns out, I think, for significant figures. So I think different textbooks might say different things. But I think the usual interpretation is we are certain about all four of these digits that I put here. And maybe the next one would have uncertainty in it. And in that sense, if somebody added another 0 here, because for whatever reason we just happen to measure exactly 12 meters, but we want to indicate that we're more certain than that, then we add significant figures to indicate that. I mean, of course, real measurements don't always turn out exactly 12 meters. Maybe they will actually be like 12.13 or whatever, right? But again, that's like, if I wanted to convey with significant figures how precise this is, this might be like, at least to the nearest centimeter, it looks like it's precise. What would be a way of doing that, though, with error intervals? You can get even more descriptive, I think, language-wise with error intervals. So in that sense, I would argue error intervals are kind of better, but they're a little more difficult to work with, is kind of part of my answer to this. So that's like, I guess that does answer, because it says, so what's better? I'm saying error intervals, but the downside, more difficult. So for example, if with an error interval, if I wanted to say 12 meters plus or minus, now if I claim it's roughly corresponding to this, maybe what it could be is 0.005 would be the uncertainty, the estimated uncertainty here, because this would probably say that up to at least this digit, we're pretty certain, but then the next digit has some uncertainty indicated by, it could be up or down by 5, which may actually affect the rounding of the next digit. So this may be even too big. In that sense, if instead of that, one could argue, oh, maybe it should have been just like that, like a 1 there, or a 2 or a 3 or whatever, right? Maybe something smaller. In that sense, you can convey more with error intervals. Now, one adjustment I want to make, though, there's actually kind of a mistake here. What I did here is kind of bad form. If I have plus or minus this much here, which I think is maybe conveying a similar story as this one right here, although again, there's maybe some debate as to what exactly that number should be right there, but it's definitely bad form to have sort of a mismatch here in terms of what power of 10 we're rounding at. In other words, what decimal place we're rounding to. So I think what I'm going to do here, let me erase this arrow and let me make a little more space here as well. Move this thing over a little bit here. And to make this thing work, I think what I'd want to do is, this is at the thousandth, right? Because it's tenths, hundredths, thousandths. I'm not good at basic math. I gotta still count that out there. But I want to make sure that I've reported this number out to wherever, like whatever the smallest, you could say, power of 10 that the estimated uncertainty is rounded to. So that's one of the rounding rules. We're going to see some more information about that in the lab portion of this course, so you'll probably get to read about it a bit more. But again, I think this tells kind of a similar story as this one. Note there's some differences, though, right? Because I said this is maybe similar to this one, but yet I included one more digit here. And like I said, when it comes to doing calculations, this is a whole other part of this. Is like, if I now said, oh, I'm going to like multiply this by some other length to get like an area. With significant figures, there's a relatively easy set of rules for figuring out where to round in a result from something like that. When you're doing error intervals, the story is a little bit longer, and we're going to learn some parts, a good deal of the parts of that in lab again in this class. So again, it's better to use error intervals in the sense that it communicates more information, but they are more difficult. And I kind of put a little joke here in the answer. I said errors are clearly better, because sometimes this is kind of like a physics class versus chemistry class kind of like rivalry things. Like physics class, you tend to do the error intervals a bit more, and in chemistry class, you tend to be a lot more attentive to significant figures. So it's like there's a slight, just different mindset between the two disciplines.